Hello everybody and welcome back. So in this video you are going to learn about object oriented programming in Python and how you can create your own custom objects by making different classes in Python. Now this video is geared towards beginner. So people that have some knowledge of Python have written Python code before, but I have not yet stepped up into kind of the intermediate stage, which I am going to call is this working with classes and objects, and are looking to learn that. So I am interested completely from the beginning. If you have no knowledge of object oriented programming, that is totally fine. In this series, it's meant for you. If you are someone who just wants a refresher, I would recommend maybe watching the video on 2x speed and slowing down when things get a bit more confusing, or when you know you need to really learn the topic more. So let us go ahead and get started. And what we need to do discuss object oriented programming is first to find what an object is. Now a lot of people may think that when we talk about or object oriented programming, that is a completely new thing. You know, you have never seen an empath on before, and it is a new kind of thing to tackle and to learn, when in reality you actually see objects all the time when you are working with Python code, and you just don't know that they are objects just because they are a little bit discussed. And I am going to kind of take away that disgust and show you what all these different objects are. So we may have heard of the notion of type before we see this function type, and we know when we ask it what type a certain variable is, or we ask it what type, say a string is like this, it splits out an answer to us, and I will show you what I mean by that. So if I do print type of hello, so we know that hello is a string data type. Let us just see what we get in our console down here. Oops, I did not mean to do that. We get class string. So notice that this says class. Now most people just disregard the fact that it says this, but this is actually very important. What this is telling us is this right here. The string that we type in is actually an object of the class string, right? str. Now what do you think is going to happen when I put in x? Well, we know that x is an integer, so let us have a look. Here we can see that we get class int. So notice that these different data types that we have called them before a string and an int are actually a part of the class. And what that means is, even though it does not look like we have created an object, when we do something like x equals 1, we have said x is equal to the object, which is a type integer with the value 1. That is exactly what we have done, and the fact that we create these kind of objects is very important in writing Python code. And I know hopefully should not confuse any of you too much, but if I write say a function, so define hello, and in here we just print hello like that, and what I decide to do is I go, okay, let us look at the type of hello. So notice I did not call the function hello with the two brackets. I am just looking at the actual name of hello, and we run this well. If we add the final bracket at the end here, we get class function. So pretty much Everything in Python that we work with is actually an object of some kind of class, and later on in the video what we are going to do is make our own classes so that we have our own specific types. So these are what are called the built-in types. These are built into the Python language, and that is why they work a little bit differently than other classes that we will work with later. But just understand that whenever you create something in Python, you are really creating an object which is an instance of a specific class. In that class defines the way in which that object can interact with other things in our program. And just show you what I mean by that, let us just look at some common error messages and we will see exactly what that means. So we are going to say x equals 1, y equals hello, and watch what happens when I try to do something like print x plus y. We will get some error. Let us go up and see here. We get type error, unsupported operand types for plus, int and string. So it is saying because our object x is an int and our object y is a string, we cannot add them because the program does not know how to work with objects of those two types. Or in better words, the addition operation is not defined for objects or int and objects of string at being added together. So it is very important and pretty much the type that we have defines what we are allowed to do with the specific variables or with the specific object, and it denotes the actions that we can perform. You know, plus, minus, all of that. If I were to change this right to 2 and then we just do x plus y, don't need to print it out. We can see that that is totally fine and there is no issue because these are both ints, which means that operation is defined for them. Okay, so hopefully that is clear and that makes some sense. I hope that gives you kind of understanding of what I mean by objects. And now I am going to talk about methods because those are something that we can perform an objects. So I am sure that many of you seen this before. I am just going to type string equals hello like that, and many of you know that we can do something like print string. If I can type this correctly, dots up, right? So when I write this dot upper here, what is that exactly doing? Well, let us look at here. We obviously know that puts that all to uppercase, but we are allowed to use this what we are called method, and this is a method. Whenever you have this a dot operator, you have some name and then you have the two brackets at the end here, and maybe there is some arguments that go inside of there. This is usually a method that is acting on a specific object, and in this case what it is doing is we have the method upper acting on the object of type string that is stored in the string variable, and the reason we are allowed to use this method on it because this is a string. Now notice that I can't do something like x equals 1 and then do x dot up, and the reason I cannot do that is because while it is going to say right here int object, notice int object has no attribute upper. So these methods, these different operations, the things that we can do with these objects is based on the type of class that they are. So that is something that we really need to nail in here, and I hope that makes sense. And now what I am going to show you is how we can actually create our own classes, because hopefully that give you a good enough explanation for what objects really are. So to create our own class, I am going to kind of do like a template here, and then we will go back through and discuss what everything is doing at once, but just try to follow along for now. So I am going to say class, and we are just going to do the classic kind of animal example to start here. So I am going to say class dog, and we are going to define this initialization, which we will talk about later. And actually, no, let us not even do that. Let us just say define bark like that. And then what I am going to do in here is simply print work. Okay, so what I have actually done here, and I know this is going to be weird for many of you that have not seen this before, is created a class called duck. What this means is I am going to make my own kind of blueprint. Now for the objects that are of type dog, and I am going to start defining the operations that a dog is able to do. Now in this case I have created a method. Now a method is essentially just a function that goes inside of a class. That is the easiest way to define it. And for our basic example, right now all of our methods are going to start with a parameter called self, and we are going to talk about what this self parameter means and how all this works later on. But let us kind of build our way up to that. So I am going to say d is equal to dog, and what I have done when I did this, here I am actually saying okay, I am going to have the variable d, and I am going to assign it to an instance of the class dog. So this is class dog. Again, you don't need to know how this works right now. We are going to talk about that in a second. But when I write this line here and I put dog, which is the name of my class, and then two brackets like that, I am instantiating, right, creating a new instance of class dog. So D is now going to be an object that is of type dog, and notice that we don't get any errors there. And when I decide to print out type of D, we are going to see that we get class underscore. Underscore main underscore r squared dog. Now the reason we have these underscores is because this is telling us what module this class was defined in. Now by default the module that you run is called the main module. That is why we have these two underscores, main underscore underscore, but we can see that this is again an object of the class dog, and that means that whatever we define inside of here is going to be what is allowed or operations that can be performed by a dog, and one of those operations is bark. So this is a method. Remember, we have talked to a method just like dot upper before. So if I want to use this method on an instance of my dog class, because this is an instance of the class dog, then what I can do is I can type well, not upper but dot bark like that. So I can call this method on my dog object again, because it is a class dog and I have defined a method that works for dogs. So when I do that, we can see that we get bark, and then it still obviously continues to print the type of that object. So this is what we are getting out here. So these are kind of how classes work. We name the class. Typically the convention is to use the upper class later, and usually you go camel case. So you do like dog, like you say we are going to do two words. You do like dog, hello, right? So camel case like that, and then inside of the method or inside the method inside of the class, you can define a few different methods and operations that can be performed by this object. So what I am going to do is I am going to say define. I don't know. Later just say meow. I know this is wrong because it is not a dog, and we will talk about self in just a minute. But I can define another method here, and instead of printing something I could say return. Let us just say yeah like that. So I don't necessarily need to print something. I can return something. I can have sense something. I can have these methods take arguments. So maybe I have meow, and then I put x, and maybe what I do is one I return x plus 1 or something like that. So maybe let us just call this add underscore 1. That will be the name of our method. So I can return x plus 1, and then what I could do if I want it here is like it is a dog, add underscore 1, put 5 there, and let us print out the value that we get. Let us have a look at this year, and we can see that we get the value 6. So we can make methods that have different arguments associated with them, or parameters like I have put x here, and that just means that when I call that method I need to pass in a specific value or specific values so that that can operate and that can work. So that is how the method works. So now we are going to talk about itself, but before we can do that, we need to talk about what is called the init method, which you may have seen my typing at the beginning. Before I kind of gave up on X, I didn't want to get that complex that fast. So right now we have two methods. We have this bark method, and we have this add one method, and I hope those make sense. So right now we have two methods. We have this bark method, and one have this add one method, and I hope this makes sense on how those works. And now we are going to talk about this special method here. And by the way, this has two underscores, so it has underscore underscore, and then an init, and then underscore underscore. Now this is a special method, and what this pretty much allows us to do is instantiate the object, right, when it is created. So this method will be called whenever we write this line. So whenever we create a new dog instance by writing dog and then the two brackets, let me get rid of this down here. For right now, this method will be called, and it will pass any arguments that we put in here. So maybe I put something like team in here. I will pass that to this method. So let us say that every time we create a dog and we want to give it a name immediately. So to create a dog, the criteria is that you must give it name. Well, what we would do in here is we would put the parameter name, and then here we would pass in the name. So what we need to do enough is what we are passing in this name. We need to store this in the dog object somewhere, right? We need to have this stored. We need to be able to access this. This is kind of the nice thing about objects. And this is where we are going to talk about attributes. What we can do if we want to store this name is we can say self.name is equal to name. Now it is important to note that these don't need to match. But what we have just done here is we have created what is called an attribute of the class dog, which is name. So what this means is essentially every time we create a new doc object, we will pass a name through this parameter. So self just says here to denote the object itself. So, like every time one of these things is called, we will pass a reference to which object is it was called on. So, we can access things for each specific object, and we will talk about that more in a second. But here what I have done is to find an attribute called name, which is equal to the name that we pass in. So what I will do is immediately I will just print inside of here the name, so that we can see how this works. And notice that when I run this, now we get team printing out. So even though I did not explicitly call this in it method, because I wrote this line here, I passed this name that I put in here to the name parameter, and then it printed out name here inside of the anet. And we also define an attribute called name that is inside of this doc class. So what self is doing is every time that we of these methods is called kind of invisibly, you don't get to see it. The actual reference to this dog object is passed so that we can access attributes that are specific to each dog. And what I mean by that is I can make another dog. So maybe I say D2, which is another instance of the class dog, except this time I named it Bill. And now we will do the print statement again. So we will say print name just to show how this works. And here we get Tim and we get Bill. So we actually have two different dog objects. Now one named Tim and one named Bill, and they both store different names inside of their instance, if that is what you want to call it. So let us just show how this attribute works. So the point of this attribute is that it is stored permanently for each specific object. So I can actually go ahead and go down here and print d dot name. After that defines, and I can print d dot name like that. And when we look here, we can see that these names get printed out. So Tim and Bill. Notice that I remove the print statement from up here. So these attributes, when we do something like a self dot and then anything that we want, we can call whatever we want is equal to some value. We can reference them later on, and we can reference them from methods inside of our class. So an example of that is something like say define get underscore name. So the first argument here is always going to be self or the first parameter. And the reason for that is because we need to invisibly pass the actual dog object itself, so that we know we dog were accessing when we are going to get say the name of the dog. So here we are going to say define get name, and all we are going to do is return self dot name like that. So now rather than saying dot name, we can call thought get underscore name, which is a method, right? And we can do that down here as well, and underscore name, and then we see that we get team and we get bill. So that is the basics behind objects. Now, of course, I can make more attributes as well. So I could do something like age. So let us say my dogs, I want them to have a name. So let us say my dogs want them to have a name and an age. Well, what I will do now is I say okay. So now in our initialization for dog, we are going to take a name and we are going to take an age. So we will define the attributes in the here. So self dot age is equal to whatever age we pass in, and now every time that I make a new dog object, I need to pass a name and an age. So this team will be an old dog. Here Bill will be a young one, and we will run this and we will see that we get no issue. And if I wanted to, I can go ahead and define another method here. So get age, we will return self dot age like that. And if we change this to get age and we change this one down, here we get age as well. What is the issue here? Offs. No. So I am forgot to put myself in here. So notice what happened when I forgot to put myself. So that is actually a descent error to run into. I did not put self in here as a parameter, and you can see I know that it is kind of messy here. It says get age takes 0 positional arguments, but one we are given. So what does that actually mean? So it is saying it takes is your arguments, which it did when I did not himself here, but one was given, but I did not give any arguments inside of the brackets. Well, that is because when we call a method this write the actual dog objects itself, immediately kind of bin blee gets passed to that method as the self parameter. So we know which dog it is talking about. So now if I go ahead and I add self, we can see that this works fine, and we get 34 and we get 12. So that is important thing to remember. Now what we can actually do is we can create another method that modify these attributes or create new attributes. So I can do something like, for example, set age, of course, and then we will put an age here. What I can do now is say self dot age is equal to age, and now what I am going to do for team, and we will get rid of bill for now, because I think we get the point on how it works for different objects. Is not going to say d dot set underscore age. So I am going to change his age to 23, and when we print it out we can see that 23 actually gets printed out. So we can modify and we can access these different attributes from methods inside our class, and this is where things get very powerful, because this allows us to access data that is stored within a specific object and do different things with it based on how different methods and different things are being called, right? And this just is pretty much the blueprint that defines how a dog actually works, how it operates, what it can do, the methods associated with it, and the attributes that exist. Now some of you may be saying, well, why do I need to do this, right? Like this seems kind of redundant. I could write in a different style. Well, the nice thing about object oriented programming is once you create one of these classes, you can have an infinite amount of instances of this class without having to change anything. So let us say, for example, that we will leave that class up here right now, but we want to simulate what we have just done here for the team dog, right? We want to have an age and we want to have a name, and we want to be able to change his age and all that. Well, many of you that were more beginners programmers would probably tell me we can do something like this. We can say dog1 underscore name equals team. You could say dog1 underscore age equals to no 34, and there you go. You just define these two attributes if you want to get it. You can just access the variables. If you want to change it, you can just change the variable. Okay, nice. But what happens when I want to make 25,000 dogs, or every time I run my code I want to make a different amount of dogs? You cannot find a way that you can write all the different variables that have 1, 2, 3, all the way up to 50,000 or however many dogs. I have to represent that. That is why we use object is whenever we are going to be kind of reusing something. There is some instances in which we make a class here that we are only going to use once or instantiate once, but those are kind of more complex examples. We won't get into here, but then okay. So some of you might tell me, alright, well, team, I can just do list. I can say dogs equals that, we say dogs underscore name equals that, right? And here we can put, well, the first name is team, and then we find bill. So this will handle the idea that we cannot just have all these different variables, right? So does age equals, and then we go, let us say I don't know, 32 14. Okay, that is great. But the issue with this is that it is really a pain when I want to access the dog's age, the dog's name, and then what if I had like 25 other attributes or methods associated with the dog? This is just a pain. You don't want to deal with that, because I have to know, find the index of whatever dog I want in one list, which is a very time consuming operation in computing, and then I need to reference that index and all the other list for all the other attributes, and it just becomes very messy very quickly. And let us say I want to delete one instance like feed, the dog object bill or something like that. Then I need to find the index of this. I need to find the index of all the attributes and all the other lists, and I need to delete them at the same time to make sure that all my data stays inconsistent and there is no kind of offsetting things or too many attributes in one list. So it is just as a pain to do it like that. So I hope this makes sense on why we would do object oriented style. And now what we will do is go into one example where we create a more complex object and show kind of the advantage of that. Okay, so a lot of people typically will storm at kind of previous example that I just gave you. Now I want to go a little bit further and show you the advantage of doing multiple classes. So rather than just using one class, I want to show you how different classes can kind of interact in an example where I have a bunch of students. These students all have some grade assigned to them, and they are all a part of course, and then that course will have some methods on it to do things like find the maximum grade of all students, give us the average grade of all students, tell us the lowest grade, some things that you may actually want to do. Say if you were trying to model or create a system for a school or something like that, right? So this is obviously going to be a little bit more of an example as opposed to super practical. but hopefully this should give you some more insight into how we would do something like that. So I am going to start my creating a class called student. I am going to go a little bit faster here, but I will slow down and talk about what I have done after. So don't worry if you cannot keep up. So we are going to have a student, and each student is going to have a name, age, and ed grade. So we are just going to say self the name is equal to name, self dot age is equal to age, and then self dot grade is equal to grade. Now this numeric grade is going to be between 0 and 100, so I will just write down here, so we know that, and that should be good for our students. So we could of course go in here and add some methods if we wanted something like get underscore grade. And what does I d1, just so we have in it here. And what we can do is return a self grade like that. Okay, so this is where we are going to leave our student. Now we could add a lot more things to this. We could add a change grade. We could, add a test. We can have a weightings. Yeah, we can do all kinds of crazy stuff. But for now, we are going to leave it at that. So again, we have defined three attributes here. We have a name and an age and a grade. Those are equal to the name, age, and grade that we pass in when we initially create a student, and then we have one method. Remember, this is a method and it simply returns a student's grade. Now I am going to make a new class called course. Now what I am going to do is, in this course classes, I am going to have the ability to add students to a course. So when we create a new course, what we are going to need to do is, we need to define the name of the course and the max underscore students that can be enrolled. So in here we will say self dot name is equal to name, and self dot max underscore students is equal to max underscore students, like that. Alright, so what we are going to do now is, we are going to add a method that will allow us to actually add students to this course. But how we are going to do that? We going to have students stored inside of a course object. Well, what we can actually do is, we can make a list of students. So I am going to say self dot students is equal to a blank list. Now notice that I have made an attribute and I did not assign it directly to one of these things that was passed into one of these parameters arguments. Whatever you would like to call them, that is totally fine. In fact, a lot of times we'll create attribute like self dot, is active, something like that equals false, right? We can do that. That is totally fine. And attributes are just whatever we decide to define, and if we want to assign them to say the argument or parameter that is here, that is fine, and we can do that. So there we go, we have self dot students, which is a blank list, and I am going to start by creating a method here that is going to allow us to add a student object into this list. So I am going to say define add underscore students, like that, and in here antic self, and we are actually going to take student. Now the student right here is actually going to be an instance of a student object, and I will show you what I mean by that in a second. But all we are going to do is say if the length of self dot students is less than, and in this case self dot max underscore students, Then what we will do is we will say self.student.append student. So we are going to create a list of students inside of this. You know this list right here, right? That is what we are going to do, and we are going to add them in only if this is less than the maximum students in the class. And what I will do is I actually return true if the student was added successfully, and then down here I will return false if not so. That we can tell maybe if we make a program down below if that student was added properly or not. Now I am going to add another method, and here I am going to say define yet average grade. Now all code that one out in a second, but let us do an example of how we can actually now add students to this class. So I will make that a bit smaller so we can read it. So let us make a few different students. So let us say S1 is equal to student. What do we need to pass for student and name agent and grades? Let us call that team. Let us call that 19, and let us call that 95. Team is a smart guy. Alright. And then we will do S2 is equal to student. We are going to say Bill. We will put him at 19 as well. And he is not as smart, he is 75. And then later do S3 is equal to Jill. Keep with the trained team. Bill, Jill, and maybe C was a 65. Okay, so we have created 3 students here, and these students are proper, they should work fine. Let us run this. Make sure everything alright. Now how can we actually add them to our course? Well, the first thing we need to do is make our course. So we are going to say course is equal to course. Like that, what do we need when we make a course? We need a name and we need a maximum amount of students. So let us name this course. Let us say science or something like that. And let us say the maximum amount of students is actually going to be 2, because I want to show what happens when we add a student past the maximum. Now we are going to add students. So how do we add them? Well, we have to call that method. So course dot add student. So there we go. We can add student S1, and then let us do course dot add students again, and let us add S2. So now let us run this. We see everything works fine, and let us actually make a thing that can print out something about our student or can show our student. So what I could do is I could say let us print down here course dot and this student, and let us have a look here, and we get main student object on some gibberish location, main student object at some gibberish location. So what this is actually telling us is both of these things inside our list right now, our student objects. And notice what I can actually do is let us say first index the 0th item in that list. So the first student that we added, and I decided to call dot name on it. Well, then that should hopefully print out the name of that first student, which is 10. So that is cool, and that is how we do that, right? We can add things into this course. So now this course stores all of our students, and since all of these students have a grade on them inside of our course, we will be able to access that. So now that we have done that, let us write this method that can get the average grade of all the students that are enrolled in the course. To do that, what we are going to need to do is grab all the students from the students list. We are going to need to add that to an average, and then we are going to need to divide that value to figure out. So what we will do is we will say value equals 0. We are going to say for student in this case self dot student. Then we are going to say value plus equals students. The duck gets grade like that. Now notice that we could just type grade if we wanted to, but I usually just like to use the method because say we were to change any attribute later, then this code would not break so long as this method will still name the same thing, and we can modify the method in here so they return the proper grade. Like say we had a student enrolled in multiple courses, then we could, determine their grade in a different way. And when we called get grade, maybe we don't just return self grade, we return something different. So this will continue to work. So we will say value plus equals students grade get grade, and now all we'll simply do is return in this case value divided by vlen of self dot students. So let us see what the average grade of our courses. So course get fabric grade will actually print out like that and run that, and we can see that the average grade is actually 85, and that makes sense with the grades that we have here. So that is the idea behind what I am trying to show you, is that we have, we can have different classes, we can have attributes with them, and when we can program an object oriented style, now it does not matter how many students we have or how many different courses we have, and what students are enrolled in which. In fact, what we could do is we could make another course, we can add the same students to it, and then we would obviously have to change the way that their grade was calculated, but that is something that we could do. Now let us just look at what happens when I decide to try to add that third student. So course start as student like that, and we decide to add student s3. We can see that we get the value false, and notice that the average grade does not change because we did not actually add that into the course, right? Okay, so we finish off the basis on the classes and objects and how to create our own classes, and hopefully that last example helped you to really kind of understand the advantage of doing this. Now what we are going to talk about here is something called inheritance. Now this is where we slowly start getting to a little bit more complex and some more difficult concept, but I don't find inheritance as that extremely difficult. So the idea behind inheritance, and we will show what that is in a second, is you have two classes that are very similar. So let us say we have a general class called maybe alright. Let us do a better example. Let us say we have a class called dog and a class called cat, and in fact let us actually code these out so that we can see this for real. So let us say in the init method of the cat, what we are going to do is we are going to have self name and age. So we are going to say, self dot name equals, if I can type properly, which apparently is not happening right now, and then self dot age, and then we will do define speak, and all we will do in here is just print, what is this cat. Yeah, okay, and then let us say we have a dog. So we will say class dog like that. We will define underscore net on our spender square. Put the self, put the name, put the age, because that is all we want to for that. And we will say self dot name is equal to name, self dot age is equal to age, and then define here speak. And the only difference between these two classes is actually going to be the fact that this print bark instead of meow. So notice that these two classes are almost identical. In fact, there is only one line of code that is different other than the class definition at the top. So there must be a way that we don't need to write this twice, that we can usually use what is called inheritance, so that this dog and this cat classes can well inherit from an upper level class, which means that all that functionality is defined in one place, and we only need to write what is different about these two classes inside of them. So ideally, what I would like to have is to be able to remove this init class from both of these and just have the speak method, because the only thing that is specific to a cat and a dog, at least for my example, is the fact that one of them says meow and one of them says bark. So let us get sure how we can actually do them. So by removing that, was an init method, and just having these methods here, what we need to do is make an upper level class, which I am actually going to call pet. So I am going to say class pet. What I am going to do in here is define that an init method that we had before. I am actually going to define a, let us say, show. So this show method is just going to show me all the things about my objects. So I am going to say print, and in here we are going to say, I am actually going to use an f string. You may not know what that is, but don't worry about it. I am self dot name and I am self dot age years old. Okay, so what I have done is I have defined this pet class, and this pet class essentially is going to contain the functionality that I want the cat class and the dog class both to have. And then inside of the cat class and inside of the dog class, what I will do is I will define the method or the attributes or whatever it is that I need to do that are going to be different for this specific class. So notice that pet is general. We call these generalization, whereas cat and dog are more specific. So how do I actually allow the cat class in the dog class to use this functionality? Well, what I can do is simply add brackets and write pet. Now what this stands for is I am inheriting the upper level class pet. So we are saying this is the general class. This is a more specific class that is being created and inherits from pet. And the same thing with dog. Let me show you how this works. So let us create an instance first of all of the pet class, and then we will make one of the cat and the dog class, and I will show you how it works. So let us say p is equal to pet. Notice that for pet we need a name and we need an age. So let us say it is him. Let us put him at 19, and then let us do p dot show. So let us look at this year. I am Tim and I am 19 years old. So that is how the pet class works. Pretty straightforward. Now let us make a cat class. So let us say C. We are going to say C is equal to cat. I am going to say the cat's name will be Bill, and that cat will be 34, like that. And then later do the same thing here. See nutshell. Now notice that even though there is no method called show inside of cat, it still pops up and says I am Bill and I am 34 years old. That is because it inherits the properties from the pack class, because I have defined that up here. And notice that even though I did not define in an init method in here, this still work fine, right? There is, this was okay. We initialize because we use the init method that was defined inside a pet. And of course we can do the same thing with dog. So we can say D is equal to dog. What do we call this one before Jill 25 and later do D dot shell? Like that we go. I am Jill and I am 25 years old. So that works. But now let us show what happens when we call speak on the cat and the dog. So if I decide to call speak like that, and we will call it on both of them. Here you can see that we get me out and we get bark. And again that is because this speak method is different for the cat class and different for the dog class. And since it's defined inside of here and we created an instance of cat, when we make a cat instance, well, we are going to use the speak method that is defined here. And in fact what I could actually do is define speak up here, and I could say define speak, and I could say print. I don't know what I say like that. Okay, and then if I decide to change this from show to speak, notice that we are calling speak three times. Speak is defined here and it is defined in both of our child classes is what we call them. So when this is the upper level class, the more general version, any classes that inherit from it are known as the child classes or the derived classes. Hmm, that is not that important to know, but just figured out through that lingo out there. And notice that when I run this we get, I don't know what to say, meow and bark. So if there is a method defined in the lower level class or the child class that is the same name as the upper level class, it will automatically override that method. So it will take over anything that is defined in here is more specific to this class. So it will use that rather than using this upper one, right? And you might ask, well, why would we even bother defining one in here if it were just going to take it over later? Well, we might create another pet, right? Maybe like a fish or something. For example, like I can do something like this class fish pet. Like that, I can literally just define that and put pass inside of here. And how hard I can do is say, okay, let us say f is equal to fish, and then we need a name. So let us call this bubbles. Why not give it 10? And now we can say f dot speak, and notice that we get, I don't know what to say for this fish class because there was no speak to find inside of here. It used the speak that was defined in the upper level or parent class, right? The one that we inherited from. So that is the basic behind inheritance. Now it gets a little bit more complicated. I am going to show you the more complex aspects because let us say I want to add one attribute to my cat. So let us say that for cats we actually care what color those cats are as well. Well, what I would need to do that is this initialization method, right? Because I want to pass it, and when I create a cat, but I don't necessarily want to rewrite this whole thing. So what I am going to do, and I am going to rewrite the whole thing, but you will see why we would actually do this. In a second, I am going to say self name age cover like that, and now all I am going to do, let me say self dot color is equal to color. So, what some of you may say here, now that we have defined the color in here, is that what we should do is take this name and age, right? Just copy it and paste it in here. Now that would be a correct answer, but I am going to tell you why we should not do that. So the idea here is that sometimes in the initialization method of our parent, other things are happening other than just redefining attributes, right? And in that instance it would not be correct for us to simply omit the fact that we are not going to call this net from the parent. We are just going to define the attributes, because that could mean that we miss out on a very important function that is happening from inside of this initialization. To give you an example, like saying some web applications, maybe this initialization actually calls a database, right? And ask for some information for a database, and it sets up the object using that, it would not necessarily be correct. Then for me to just take the attribute that we are in here and just redefine them as attributes, here I would actually still need to call that initialization to make sure the object was set up properly. So to ensure that that happens when we do the inheritance like this, we do need to define the arguments that we need are the parameters that we need for the parents initialization. So name age, but there is a fancy way to call that. So rather than rewriting this, here I can usually explicitly call this and set up our object that way. So to do that, I am going to say self or super underscoring square net done underscore name age. Now what this is saying is upper stands for reference the super class, and the super class is actually the pet class or the class that we inherit from here. So that is what super stands for, the class that we have inherited from. Then underscore net underscore defines the method that we want to call, right? And then name and age are the arguments that we are going to pass to that. So name and age, notice I don't need to pass cell, that is fine. We don't self, and it is going to call that. And what is going to happen is it is going to run whatever inside this initialization, then that is going to set up the name and the age of for our object. So we will have those properties defined, and then we will call self duck. They are equals color, or we will execute that line. So now we have the cover, right? And if I just go ahead and want to define here show, so I want to change the show method maybe for this cat object. Then what I can do is I say I am self that name, and I am self that age, and I am, and in this case self.color. So we can change the show method in here. And now let us go to cat. Let us change this to show. Let us add a color because we need to add a color. Now we have to find that in the anet, and let us run this and see what the issue is now, that we are getting fish is not defined. Oh, did I do? I guess I have deleted fish, or we get rid of it at some point. I did not remember. Okay, so anyways, let us run this and we can see that we have, I don't know what to say. I am Bill and I am 34 years old and I am brown, and then we get bark, right? So that is how that works for inheritance, and this is how we call the superclass or the upper level parent class, right? We need to call this initialization method before we just go ahead and do anything else, because that parent initialization may be important. It may do other things, it may call another method, right? So we cannot just simply skip that. We need to call that explicitly by writing this line. Now this line is kind of complicated syntax. You know, it is easy to forget, but try to remember it. Super again references the parent class paid, and then we have an init, and like that. So I hope that gives you an idea on how inheritance works. Now it is hard to give really good inheritance examples without going more complex and more into detail. So I am going to admit doing that for now. But just remember that when you have classes that do a very similar thing, they have almost everything identical except maybe a few attributes or a few methods. It might be a good idea to what we call generalize and make a parent class that is a general class that defines functionality will be used in all of your child classes, and that is a very common practice and object oriented programming to use inheritance. For example, a good example is something like person hierarchy. You are working in an organization, and the example we want to consider is we have managers and we have employees. Now managers have different access than employees, but employees and managers have very similar properties. They all have a name, and they will have an age, they will have an ID, they have a birth date, they have many different things, that they are the same for both of them. Well, if we were trying to model that system and we were going to program that and make that, what we would likely do is create an upper level general class called person that defines all of the attributes and all of the methods that are general to all people, whether they are managers or employees. And then we would create two child classes, one for employee and one for manager, and that would define the specific things that the manager can do and that the employee can do that are different from each other. So that is the idea behind inheritance. Hopefully that makes sense. And now let us move on to our next topic. So now it is time to talk about static and class methods, the class attributes, and in fact we are actually going to start with class attributes. Now previously we would have seen that every time we define an attribute for one of our objects, we use self, right? And inside the class we had self. Everywhere self was referring to the instance in which we were talking about in that, context, right? So here what we are going to do now is talk about class attributes. Now class attributes are attributes that are specific to the class, not to an instance or an object of that class. So I am going to do a basic example where I just create a class person and I am going to say number of people equals 0. Now in here I am going to define the init method and say to find an init like that, and we are just going to say each person will simply have a name. Keep it nice and simple like that. So self that name is equal to name. Now let us make p1 is equal to person. We will talk about what I have done in a second. Here in case anyone's confused, and let us say p2 is equal to person. Let us make this Jill. Okay, so we have this number of people thing, and I am sure a lot of you are like, what the heck is that? Well, this is a class attribute, and the reason it is not a regular attribute is because it does not use self. So because it is not defined inside any method, because it does not have access to the instance of the class, it is defined for the entire class, which means that this is not specific again to any instance. It is not going to change with from person to person, whereas we know something except that name will be different for each instance of the person class. This is not different for each instance of the person class. In fact, it is the same. So what I can show you is that I can actually go ahead and print, say, p1 dot number of people, and that gives me the value 0. But what I can also do, because this is not specific to the instance of any class, is write person dot number of people. And the reason I can write personally, because again this is specific to the class, not to the instance. So we can access it by just using the name of the class, and that actually means that I can change it using the name of the class as well. So person dot number of people is equal to 8, right? And then if I go ahead and say okay, p2 dot number of people, notice that we get 8, even though I did not explicitly change it on p2. It changed for p2 because this was specific to the class, and when I reference this, all this says is when I say p2 number of people, the way that Python interprets this is what is the type of p2. Okay, that is person. Notice you can see it is popping up here. It says person. Then let us say, does it have an attribute called number of people? No, this person itself does not. Does the class have an attribute called number of people? Yes, it does. Let us display back, and since we change that to 8, that is why we are getting that value. And of course, if we do this for p1 like we have shown, right, we will get the same number. We will get p1 number, people get 8. And if we decide to change this halfway through, right, so we do person equals 9, obviously that will become 9. Now just because we change it right before we printed the next value, so that is the basics. We be behind class attributes. There is a lot of different uses for them. Now in this case, what I want to do is have a number of people. So what I was going to do is, inside of here say person number of people plus is equal to 1, so that we keep track of how many people or how many instances we have created of this class person. So now if I decide to print p, person dot number of people, and we will do that after we create the second person as well. See, we get 1, 2, and this automatically increments it. So that is a basic example of one you would use a class attribute. They are not extremely you, but is something that you may want to consider, and sometimes say you want to define a constant, something like maybe gravity or something that is going to apply to every single person that you want to be a constant value. Then you define that as a class attribute, so that if you ever decide to take this class and use it somehow else, then constant is still defined, as opposed to putting it up here like and opposed to saying gravity up here and making it equal to negative 9.8 meters per second. At the top, what you would do is you would make that a constant inside as a class attribute, so that now every time you want to access the gravity property for a person, what you would do is you can reference directly the person's class constant of gravity rather than a global constant which may not be there if you put this class in a different file. And that is the idea behind this. These classes as well is that they are exportable. I can write a class in one file and I can take it and move it to another file, and hopefully it should continue to work, assuming it does not depend on anything from the previous file. So ideally you want to make your classes as robust as possible, which means that they don't need anything outside of their initial class definition, unless that is going to be another class that maybe it is interacting with, like in the example before we had course and we had student. But that is the idea behind class attributes. Now let us talk about class methods. So class methods are defined a little bit differently than regular methods. I will show you how they work. We have a good example kind of setup here. So I am going to say define, and in this case we are going to say number of people, like that. Instead of saying actually self, we are going to say CLS. Then what we are going to do right here is return CLS number of people, and we are going to use what is called a decorator to denote that this specific method is a class method. And to do that we write a class method directly above the function, or but yeah, I guess function method, whatever you want to call. So I know this seems a little bit bad, but the idea behind this is that a method here is not going to be acting on behalf of one instance. It is not going to be specific to an instance, and in fact you can call it on an instance if you want, but that is not really going to be very effective. What this is meant to do is be called on the class itself, so that it can deal with something like returning the number of people that are associated with this class. So these are class methods. They, that means they act on the class itself. They do not have access to any instance, and that is why I have written CLS here instead of self, because there is no object and it is doing is just acting on this class. So for example, say we wanted to add to the number of people, then what I could say is class method define add person, like that CLS, and we would say CLS dot was it number of people, like that, plus is equal to 1. So that would be, these are class methods. We denote them with at class method. So we know that they are not referencing itself, like that they are referencing the class. So let us actually have a look at how we use that. Now sure, need to necessarily print the number of people anymore. What we can do is we can go down here and say person dot number of people, and I don't know why, There is so many brackets showing up here, geese. But if we look at this, oh, what we would need to print it out. First, we should hopefully get the value of 2. So let us look. Okay, so we need to rename this so that this is not the same as the attribute because that is going to be confusing. So let us add an underscore there because I was realizing what the heck, what is going on there, and we can see that we get 0. So that is because I did not continue to add here. So actually what I am going to do is, and is this actually be a good example, so let us illustrate this. Here is, I wanted to say 2, but I forgot that. I forgot, did not continue adding this. But what I can do is actually use this class method that I have defined here to add a person. So I can say person dot add person like that inside of my init, and what that will do is call the class method on the class person, and then it will add to the number of people. So now when we run that, we get 2. So that is how a class method works. I don't need access to the instance to call it, although I can use an instance to call it if I want. I can simply reference the actual name of the class, and this does not access any specific instance. It only accesses this class attributes or anything specific to the class itself. So that has big class methods. Now let us get rid of those. So I am going to talk about another example of class methods in Python. A class method allows operations related to the class itself. They take CLS as the first parameter, whereas instance methods will take self. Self refers to any object created from that class CLS, meaning class refers to the class, not any objects. Here is an example. We will create a class of students. We will need a constructor to construct some students objects. All students will have a name and a GPA. Self.name is equal to name. Self.gpa is equal to GPA. We will also create a class variable for this demonstration of count. We will count how many students we create. Whenever we construct a student object, we will access the class of student. Student take our count variable, increment it by 1. Whenever we create a student object, increase count by 1. We will create an instance method of get info dot instance methods have self as the first parameter. We are referring to the object we are currently working with. I will return an F string where we will display the student's name and their GPA. Self.name, self.gpa. I will add a comment that this is an instance method. Now to create a class method to work with class data, we will declare a class method with a class method decorator. Class method. What we are going to do is define a method to get the count, the class variable of count. This method will be called get count rather than self as the first parameter. We will be working with a class. CLS meaning class. I will return a F string. Total number of students at a placeholder CLS. Count. Let us test this. To call a class method, you take the name of the class followed by the class method get count, and then we do need to print this. What is the count of my current students? Total number of students is 0. Let us create a few student objects. We will create student1 equals, call the student constructor. We have to pass in a name and a GPA. Let us say that the name is SpongeBob. SpongeBob has a GPA of 3.2. We will create two more students. Student 2, student 3. Student 2 will be Patrick. Patrick has a 2.0. Then Sandy. Sandy smart. In fact, she is a genius. She has a perfect 4.0. Now let us count the number of students. Total number of students is 3. When we call this class method, we can access or modify class data. This class variable of count, rather than using self, we use CLS for the class. Let us create one more class method. This time I will calculate the total GPA of all my students. We will need a class variable to hold that data. Let us say total GPA equals 0. Whenever we construct a student object, we will access our class of student, get the total GPA, then add plus equals this student GPA that we have just created. Basically speaking, the total GPA, this variable is going to accumulate all of the GPA of every student and store it as a sum. To find the average, we are going to divide it by the count, the number of students. We will do that within a class method to create a class method. Again, we need to use the class method decorator. I will define a method of getAverageGPA. The first parameter is CLS for class. I will check if CLS count, the count variable of my class, is equal to 0. That means if we have no students, if that is the case. If there is no students, we are going to return 0, because otherwise we are going to divide by 0 and we will get an error. Else we are going to return an F string. Follow this formula. We are going to take the total GPA of my class dot total GPA divided by class dot count, the number of students we have. That is how to calculate the average GPA. And after getting the count of the number of students, to access a class method, we take the name of the class student, call the class method getAverageGPA, then I will print it. Total number of students is 3. The average GPA is 3.06. Alright everybody, those are class methods. Instance methods are best for operations or instances of the class. Any objects, static methods are best for general utility functions which do not need access to class data. Class methods are best used when we are working with class level data or we require access to the class itself, such as when we are working with the class variables rather than using self as the first parameter. We are going to use CLS, meaning class. And well, everybody, those are class methods in Python. And let us talk about static methods. So sometimes I am actually in delete the entire thing. You want to create classes that kind of organize functions together. So for example, when you say like import math like that, and then you get access to all these math functions like math.abc or math.square roots or whatever it is you are going to use. What they sometimes end up doing in an object oriented programming, this is pretty common, is when you have a bunch of functions that you would normally just define, like add one like this. Yeah, I would do something to define add two like this. Well, what you want to do is you want to actually organize them into a class, and the reason you do that is just so it is a it says a little bit structured. You can move all those classes together to another module and continue to use them. And to do something like this, you want to use what is called a static method. Now let us make a class called math, and what I am going to do in here is I am going to define some methods or some functions that I would like to be able to use, but that are not specific to an instance. So I don't want them have to make an instance of this math class to be able to use these methods. I want to be able to call them at any points, and it doesn't matter or if I have an instance of the math class or not, I would like to be able to use them. So what I am going to do is actually create what is called a static method. Now static means not changing, right? It means staying the same, and that is really good way to describe what these methods do, because they do not have access to an instance just like the class method. All they do is something, they do something, but they don't change anything. That is the idea behind a static method. They don't change anything because they cannot. They don't have access to anything. So in here, what we are going to do is just say define add 5, and in here I don't even need to put a cell for a CLS, because this is not going to access anything. All it is going to do is just act as a function that is defined inside of this class. And again, some of you I am sure are yelling saying, what is the point to doing that? Why don't I just define a function globally? Well, it is more of an organizational thing, and there is some more specific applications in which you would use a static method. So I do need to show them to you. So here we are going to take a number, and all we are going to do in this method is return x plus 5. So now if I want to actually use this, what I can do is I don't need to say like m equals math like that and make an instance. That is not necessary. I can simply write the name of the class and math dot add 5. Let us put 5 in here. Let us have a look. If I got rid of the s and we get the value 10, so this is called a static method, and we can make as many of these as we would like, just as we can make as many class methods as we want. So maybe we do add 10, right? And then we have bet like that, and we can change this method to say at 10. And now if we run this, we get 50. So that is a static method. Notice it does not need anything. In fact, what I can actually do is say define. You know, PR. Let us say that is going to stand for print. Let us make this an at the rate static method, and now let us just print run. Like I'm just showing that you don't need any attributes in there or arguments, and let us just call PR. And now you can see that we get run, and since I printed the value of that, it prints them none. But there we go like that. Okay, so that is static methods and class methods. And to be honest with that, that is pretty much everything you need to know about classes and objects, at least at a beginner level. Now there is some more interesting things that we could talk about, but in the idea of keeping this more for beginners and so that everyone can kind of understand, does not get too confused, I am number frame from discussing anything further. But I hope this really gave you a fundamental knowledge of how classes and objects work in Python. A little recap here is to remember that everything we work with is an object in some sense. We have functions which are objects, we have strings which are objects, integers are objects, and what an object does is init instance of some class, and that class defines the properties and almost kind of the blueprint for that object. It says, okay, so if we have a string, we can use the method like upper, lower. If we have an int, we can add integers together. And a class, the type of an object, is very important because it defines the behavior in which it can exhibit. So that has been classes and objects in Python and introduction to object oriented programming. I hope you guys enjoy it. If you did, please make sure you leave a like. These videos are not that easy to make, and they are definitely time consuming. So I would appreciate it. Subscribe to the channel. See in the future. Thank you very much.